Welcome to True Projects. In this video, we are going to explain about the project that is identification of non-speaking and minimal speaking individuals using non-verbal vocalizations. Before getting into the execution, first let us understand what is the project about. So this project is all about person identification, which is PID. It is really important in areas like security, healthcare, and finance because it helps to make sure that the right person is accessing certain services or information. There are different ways to do this. For example, with the knowledge based approaches where people use things like passwords and pins for proving who they are. And the other option is token based methods where people use smart cards which where they need a physical item to access something. But one of the most popular and effective ways is through biometrics, that is a unique trait like fingerprints and also voice patterns to identify someone. And here voice based PID, that is person identification in particular, has become really popular in recent years. It is convenient and accurate, and it is used a lot of everyday technology like virtual assistants, think like Siri or Alexa, and voice activated devices. The big advantage here is that it doesn't require you to remember anything or carry a physical token with you. At the same time, it offers strong security because it is very hard for someone to impersonate your voice. So voice recognition is not only practical, but it also provides a solid foundation, solid level of protection. While this voice based PID, that is person identification systems, are great for the most people, they have major limitation. They mainly focus on speech patterns and the words people say. This means they don't work well for individuals who don't speak much or at all, often referred as non speaking people or minimal speaking people. So, these people might communicate through non-verbal vocalizations like sounds or gestures, but current voice based systems don't recognize these valid forms of identification. This big issue is it leaves out a large group of people who may rely on other forms of communication. It is important that these systems evolve to be more inclusive so they can work for everybody, not just for those who speak in the traditional way. At the same time, we need to make sure that security and reliability of these voice based systems are maintained so they can continue to protect against fraud and impersonation. So, the project that we are working with is designed to identify people based on their voices. But here, the interesting part is it doesn't just work for normal speakers, it also works for the people who might not speak much or use minimal speak. So, here we have designed project for both people who can speak and who cannot speak. To do this, we are using a model called CRNN, that is Convolutional Recurrent Neural Network. So it is a combination of convolutional neural network, that is CNN, and recurrent neural network, that is RNN. And here first we train the model with two different data sets. One is for non-verbal sounds from the Recanvo data set. So this is the data set used where we have non-verbal sounds. And the other is for regular speech from the speaker recognition data set. So now the cool part is about this model is that the convolution layers that we are using in this project that we have in the model. So these they help in picking up the most important features from the audio. So they help in picking up the most important features from the audio. And then by LSTM layers that we have in the model, that is bidirectional long short-term memory layers, they help the model to understand the sequence of the sounds. This is really important because the system needs to figure out if someone is speaking or making minimal sounds. And it needs to process the information in the right order. And to make everything work even better, here we use supervised contrastive learning, that is called SCL, in the first part of the model. This helps the model learn how to better differentiate between different people based on their voices. Then after, there is fully connected layer. So we have fully connected layer after that. So this makes the final decision about who the person is, whether they are speaking or not. And to make sure everything is accurate as possible, we use Mel frequency septal coefficients, that is called MFCC, to extract features from the sound, which works better than other models like spectrograms. So in short, the system is really good at handling both speech and non-verbal sounds to identify individuals. So this is the proposed system. And moving to the extension part, to further improve the accuracy, we have combined two powerful algorithms that are by LSTM and by GRU. The idea behind this combination is to utilize the benefits of both the models, that is by LSTM, which stands for bidirectional long short term memory. It is great for capturing complex patterns in the sequential data, making it effective for tasks like speech or vocalization recognition. On the other hand, by GRU, that is bidirectional gated recurrent unit. It is known for being more efficient and faster in processing the data. By combining both, we get the best of both the worlds. Deep learning capabilities from BiLSTM and faster, more optimized processing from BiGRU. This approach enhances the performance of the system, making it more effective at identifying whether they are speaking or using non-verbal vocalizations. So, additionally, we have built front end of the project using Flask framework. So, we have built front end using Flask framework. This allows users to interact with the system in a more practical way. They can input data, test how well the system works, and get predictions. After that, we have also included user authentication mechanism, ensuring that system is safe and reliable. Overall, this extension makes the system more user-friendly, practical, and accessible. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the essential libraries of Python that are TensorFlow, Keras, NumPy, Librosa, and others that provide necessary functions and tools for data processing. Model building and evaluation are imported. Then comes data loading. In this step, the required data sets such as Recanvo for non-verbal vocalizations and speak recognition for speech are loaded into the environment for further processing. Then comes feature extraction. So here the MEL frequency septal coefficients are extracted from the audio files, that is MFCCs are crucial features that represent the short-term power spectrum of sound and that are widely used in speech and audio processing. And these features, that is X, and the corresponding label, that is Y, are saved in .numpy files for the future use. Then comes data augmentation. So to enhance the model robustness, data augmentation techniques are applied, such as adding noise, changing pitch, or speeding up, slowing down the audio files. This helps the model to generalize better during training. Then comes shuffling and reshaping. The dataset is shuffled to ensure randomization and avoid any bias in training. Additionally, the dataset is reshaped into the required format for the model to give as input. Then comes visualization. The distribution of audio files across different subjects is plotted to analyze the balance of the dataset. This helps in identifying any classes that are speakers and unrepresented or overrepresented. Then comes class label identification. So each audio file is assigned a class label based on the speaker or the type of vocalization. This label is crucial for the model to learn the relationship between input features and identify the individual. Then comes data splitting. So here we split the data into train and test sets, where training set is used to train the data and testing set is used to evaluate the model. So training set is used to train the models and testing set is used to evaluate the model performance on unseen data. Then comes model building part. Here the architecture of the CRNN model and all the models which are built are designed, which typically involves convolution layers for feature extraction, followed by recurrent layers by BiLSTM for the sequence learning. Then comes training the model. So the model is trained using the training dataset. During this step, the model learns the patterns in the data through backpropagation and optimization techniques. After that, all the models which are built are evaluated through accuracy, precision, recall, and FN score, and then we have evaluated through them graphs. Then comes the front end part. A front end interface is created using Flask framework. It allows users to interact with the system by registering, logging in, and accessing the identification feature. SQLite database is used to store the user credentials. And then comes user gives input part, where the users they provide input as audio samples to the system, which could be neither a spoken or non-verbal vocalization. And then comes data pre-processing part. So here the given input, it will be pre-processed at the backend. So the input which is given, the audio sample, will be pre-processed at the backend, where MFCC features will be extracted and it will be reshaped into the format required by the train model. Then comes the prediction part. So the train model is feeded, audio is feeded with the train model for giving the prediction. Finally, outcome will be displayed through the front end, recognizing the person. So this is how we have implemented the project, and moving on to the algorithms used. These are the algorithms used to train the models for predicting the persons, that is person identification. So here we have used VGC16 for comparison, and this is the proposed model and this is the extension model. And to implement this project, basically we need two kinds of requirements, which are hardware and the other one is software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. Let's open that. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So model folder. In this, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files, which will be loaded into the project code during the time of execution. And here in this two folders, we have the data set. So first, let's open the data set of non-speaking. Open it. So here we have total 7,777 items of non-speaking. Let us listen to one of the audio. You heard right? Let me. So you heard another audio also, right? Which is of non-speaking. Let us listen to one more audio. You heard right? This is the data set of non-speaking people. Let's get back and listen to the audio of speaking people. So we have different kinds. So let's open this. So listen to this.
Banner.
You heard right? Let's listen the audio from the other folder.
Ladies and gentlemen.
So similarly, we will be having in the other two folders also. These are of different person voices. Now let's get back. And here, this is a static folder. This folder consists of CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. In this folder, we have HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in this test audio file, we have test cases that we will be using in the front end for predicting the persons. Let's get back through the audio, whether it is speaking or non-speaking. And here in this audio files, we have combination of both the speaking people and non-speaking people. We have audio of both speaking and also non-voice audios. Let's get back. And here in this app.py file, this app.py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write, execute code in individual cells, which makes it a popular choice for the data side. And this is the signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. To execute, copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the command prompt. It has been opened. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file by giving the command python space app.py and now click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is the localhost, and the port unless configured differently. So this is the localhost and this is the port. So copy this local link provided by the Flash framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test cases. That is the audios. Click on that. Before uploading the file, let's listen to the audio. So get back to the code folder, open the test audio, and it's being loaded. Just wait for a while. So this is the file that we will be uploading. Let's listen to this audio. So you heard the voice of non-speaking people, right? Let's get back to the application and upload it. Click on open and now upload it. So this given input, it will be pre-processed at the backend and then train model will be giving us a prediction. So here it has predicted as the person audio is identified as person number 6. So the person number is 6. Now let's try uploading some more audios. Click on choose file. Now let's upload this audio. Before that, let's listen. So you heard voice, right? Of non-speaking. Yeah, so now this will be uploading. Get back to the application, selected and click on open and now click on upload. So here for the uploaded audio file, here we got the prediction as person identified as 11th person. So person is the 11, person number 11. Now let's try uploading some more. Click on choose file. So let us upload this one. So let's listen to the audio.
It's Congress.
So you heard speaking voice, right?
It's Congress.
Yeah, so now this will be uploading. So the audio file number is 7. Select it and click on open. Click on upload. So here we got the prediction as the person audio is identified as Jens Stoltenberg. So the person voice is Jens Stoltenberg. So he has spoken. So that is why here we got the prediction as the person is Jens Stoltenberg. Here we got the prediction as Jens Stoltenberg because when we have trained the model, when we have trained the data set, when we have trained the model using the audio files who have spoken. So these are the people whose voices are trained. So now we got the prediction of this person's voice. So that is why here we got the prediction as Jens Stoltenberg. Now let's try predicting some more audio files. Click on choose file. So let's upload this one. Click on open and now click on upload. Just wait for a while. And here we got the prediction as person audio file is identified as Julia Gillard. So this is a person who has given the voice. I mean, the voices that we have uploaded now for the prediction purpose, it is the voice of Julia. Now let's try with last case. Click on choose file. Now let's upload this one. Click on open and now upload it. So here we got the prediction. The audio is of Jen Stoltenberg. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here the first graph which we have is a confusion matrix of the extension model, that is CRNN BiLSTM GRU with SEL confusion matrix. So this is the extension model. Here on x-axis we have predicted class and on y-axis we have true class. And here this diagonal represents correct classifications, that are true classifications, and the values which are above the diagonal and below the diagonal are the misclassifications. If you observe, there are very few misclassifications. And here we have accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for predicting the person. And here we have precision score comparison graph. This is the recall score and this is the F1 score comparison graph. Now click on sign out. In this page, by giving audio file, whether it may be of speaking or non-speaking, application will correctly predict. If it is of non-speaking, it will identify the number of the person. If it is speaking, it will identify the name of the person as we have trained. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.